use when finding the difference in a subtraction problem involving fractions. A rover needs to travel 5/8 mile to reach its destination. It has already traveled 3/8 mile. How much farther does the rover need to travel? So in this situation, we're looking at how far the rover has traveled and then seeing how much farther it still needs to go. So I'm comparing two different distances or lengths in this situation. And so I'm thinking that a number line is going to be a really great tool to help me visualize what's happening. So I'm going to start off by drawing myself a number line. And since my problem helps me know that I am looking at fractions that have a denominator of 8, or they're broken into 8 equal pieces, I'm going to decompose this number line into eighths so that I can figure out how much farther that rover needs to travel. And I know that I'm going to start at 0 and I would finish at 8/8, which would be equivalent to 1. And now I'm going to just add my eighths along the way, or decompose this number line into eighths to help me visualize what's happening. So here's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. Now, again, just like when we draw a fraction strip model or a fraction circle, I want my increments to be close to correct, but if they're not exactly perfect, that's okay. If they're not spaced perfectly, kind of like between my 7/8 and 8/8, that's totally fine. So now what I'm going to do is I'm going to use a bar model like we did yesterday to help me figure out and visualize what I have in this problem. So I'm going to draw my bar model from my 0 all the way to my 1 whole, my 8/8, and I can split it into 8 sections using these little hash marks on my number line as a guide. And then I'm going to start shading in this model. So I know that the total distance that this rover needs to travel is 5/8 of a mile. So I'm going to shade in 5 out of these 8 sections. So here's 3, 4, 5/8. And now this is my total distance. So I'm going to label that just to help keep myself organized. Now what I'm going to do is I'm going to draw a second bar model. And this second bar model is going to help me visualize the distance that has already been traveled. And I'm going to split it up the same way that I did with my bar model for the total distance. And then I'm going to shade in that distance that they've already traveled, which I see is 3/8 of a mile. So I'm going to shade in 3/8. And I'll label that over to the side that this is the distance traveled so far. Now what I'm going to do is I'm going to think about the difference between these two distances. And I'm going to use the model to really help me compare. I see here that when I compare how much of my model I shaded in blue for that total distance and how much I shaded in red for that distance traveled so far, I see that there is a difference of 2 sections. And I know that each one of these sections is 1/8. So that tells me that the difference here is 2/8. The equation that we just modeled was our total distance that we need to travel, which is 5/8. We subtracted the distance that we've traveled so far, which was 3/8. And we're found that we're left with 2/8 mile that have yet to be traveled. Here we use this comparison model of subtraction where we compared our two numbers, our fractions, in order to help us solve. This comparison model is super useful in situations that ask the question, how much more, right? And that was what we had here. How much more or how much farther does that rover need to travel? We used fraction models to show the parts that are being compared, 5/8 and 3/8, and then we counted how many more parts are in one fraction model than in the other.